Hey now, what's up, party people? We're gonna do some Code Katas. I think we are on convert string to camel case. So what we need to do is we need to complete the method function so that it converts dash underscore delimited words into camel casing. The first word within the output should be capitalized only if the original word was capitalized, known as upper camel case, also often referred to as Pascal case. So we're given a string like this. We need to remove the dashes or underscores. We need to return the first word. If it's capitalized already, it needs to stay that way. If it's lowercase, it needs to stay that way. And then we need to capitalize every other word in the string. Stealth needs to be capitalized, warrior needs to be capitalized, and then we need to join them together and get this as our output. Cool. So let's bring it down locally. Open it up in VS Code. Bring our title in. And let's grab our function. Nope. And let's bring in our test. Cool, let's start up Quokka. So we're gonna go ahead and get rid of these messages. Piss me off. Cool. So right now we're getting undefined returns. What we want to end up with is the camel case version of the string that we're passed. So from the get-go, we need to remove these underscores and dashes. So what we can do is we can say string equals string dot replace. And we want to replace underscores and dashes. We want to do that globally over the whole entire string. And we want to replace it with a space. And then we want to go ahead and split our string also, so we can get each individual word. So we're going to go ahead and split on a space also. So now if we log our string, you can see that all the underscores and dashes are gone, and we're getting each individual word. So now we need to loop through our array, look at each individual word. We need to return the first word just from the get-go. Doesn't matter if it's capitalized or lowercase. So what we're going to do is we're going to say string dot for each and that will take in our word, and we'll say if, oh, and we're gonna need our index too. So let's go ahead and grab our index like that, and we'll say if our index is equal to 0, then we know it's the first word, and we're gonna need a place to store our built-up string, our camel case string, and we'll call it camel string, and that will equal an empty array. And in an array like that, an empty array like that, you can think of it as like a box for us to store different values in. So if index is equal to 0, we know it's the first word, so we're just going to go ahead and push it into our box straight from the get-go. So we'll say camel string dot push, and we'll push in our word like that. And these should not be curly brackets. These should be, oh yeah, no, we're good, okay. Else, if it's not the first word, we want to say camel string dot push, and what we want to push in is our word, but we only want to grab the first letter of our word, so we're going to do it at 0 like that, and that'll just grab the first letter, and we'll say dot to uppercase, and that'll uppercase our first letter, and then we'll say plus, then we want to grab the rest of the word without the first letter, so we'll say word dot substring, and we'll pass in 1, and that'll give us the string without the first letter. So now we're just combining the first letter uppercased to the rest of the string without the first letter. So let's go ahead and return our camel string and see what we get. We're gonna need to join it still. Let's just go ahead and look at it. So you can see we're getting our first word pushed, and then each other word also pushed in there, but they're capitalized now. So now what we need to do is we need to join them like that. You see? We get the stealth warrior, the stealth warrior, the stealth warrior, ABC. If it's empty, we return the empty string. Cool. Cool. I think I mean, we could do it a couple other different ways. I think we could do it with a map, but we're just gonna go ahead and just use this one. Okay, let's test it out. Cool. Let's attempt it. Nice. So all 8 of our tests passed. So let's go ahead and submit it and check out everybody else's answer. All right. What happened here? They used some regex. They got rid of the dashes and underscores. I'm not sure what's going on here. They did a replace the underscore and the dash. I guess replace takes a second argument. This is what they want to replace it with. Oh, they're replacing the dash. or the underscore with the uppercase letter. But then how are they removing the... Yeah, I'm not totally sure what's going on here. Okay, cool. Let's do the next one. Ones and zeros. Given an array of ones and zeros, convert the equivalent binary value to an integer. Example, 0001 is treated as 0001, which is the binary representation of 1. So we're given an array like this of zeros and ones, and we need to convert that to an integer. It says, however, the arrays can have varying lengths, not just limited to 4. That's fine. So I think I know how to do this one. I've done something like this before. So let's bring it down locally. JS. Let's go ahead and save this file. Get rid of it. We can save this file, get rid of it. Okay, so we have our title now. Let's grab our function. And our test. Cool. Let's start up Quokka. Nice. So we're getting undefined returned. This is our expected output. So the first thing we need to do is we need to join all of our numbers together into one number. So we're going to go ahead and this is going to be a one-liner. We're going to go ahead and return our array dot join. We want to join it like that, and you can see right here it's joining it all into one number now. And then what we want to do is we want to say I think we want to call parse. We do it with parseInt, and we're going to let this be our first value. So we're going to say parseInt, and then this will be our first value, and then we need to pass in 2, and that gives us the integer value of the binary. And you can see that it worked. 1 1 2 2 15 15 6 6. I'm not totally sure why this works, but I've done it before. We could look it up. I think we've looked it up before. So parseInt function parses a string argument and returns an integer of the specified radix, the base in mathematical numeral system. So yeah, I have no idea. So the first value that we pass in is the string, the second value is the radix. Radix is an integer between 2 and 36 that represents the radix, the base in mathematical numeral systems of the string. Yeah, that's above my pay grade. I don't understand what that means. But regardless, it works. So let's go ahead and let's bring it into Code Wars. Let's test it. Let's attempt it. Nice. All 50 tests have passed. So let's submit and see how other people solved it. I bet you they're all gonna be pretty similar. right, so we can see that the first one is exactly how we did it. Parseint, array.join, and 2. Same thing here. They did a reduce. They did some bitwise. Whoa, look at this. This is crazy. Yeah, that's insane. Wow. Okay. Parseint number. So they didn't need to add this number in. They could have just used the parseint. Cool. Another reduce, more bitwise. Okay, cool. Now we need to let's do our next one. Format a string of names like Bart, Lisa, and Maggie. A Simpsons kata. That's cool. Given an array containing hashes of names, return a string formatted as a list of names separated by commas except for the last 2 names, which should be separated by an ampersand. So if you check it out, we have 3 names here, Bart, and this is what we want returned. We want Bart, comma, Lisa, and Maggie. If it's just 2 names, it's Bart and Lisa. 1 name, just return the name. So that's cool. So there's a few different ways we could do it. I think what we want to do is, let's go ahead and bring it down locally and we can figure out what we're going to do. Let's go ahead and let's clear this whole thing. Let's go ahead and code. This will be JS. We'll go ahead and get rid of all that. Cool. Let's go ahead and save this file. Get rid of it. Bring in our title. Let's grab our function. And our tests. Okay. Okay. And we can go ahead and bring those down. Quaka. Cool. So we're getting undefined returns. And this is our expected output. Commas between every name except for the last 2, which we want the ampersand. So I think how we're going to do it is we're going to use a reduce. So let's go ahead and we're going to return our names, so our array of objects, and we're going to reduce it. And our reduce is going to take our accumulator, our name, and our index. Right? And we want to say if index is equal to 0, then we want to return just the name. So we'll say return name, and that gives us our object, and we'll return the name. Name.name. So you can see here for the one that's just a single name, it's returning Bart. Right? So then we want to say else if we need our parentheses, else if our index equals names.length minus 1, which will be the last index, then we want to return our accumulator plus our ampersand, plus our name, which will give us our object, and then we want to return name. Right? Cool. So that gives us our last name plus the ampersand. You can see that here. We're building it up. And then we want to say else. We can move our else up here as so. We want to return our accumulator plus comma with the space plus our name. Name dot name. Cool. And then we want to reduce that down string. But the thing is we're missing a space with our and. We have spaces around it like that. And I think we did it. Bart, Lisa, Maggie, Homer, and Marge. Bart, Lisa, Maggie, Homer, and Marge. Bart, Lisa, and Maggie. Bart, Lisa, and Maggie. Bart and Lisa. Bart and Lisa. So it's working. Cool. So let's throw it in Code Wars and hope for the best. Might get some errors with this one. Let's test it out. Nice. And let's attempt it. Cool. All 45 tests passed. Perfect. Let's submit it and check out everybody else's. Okay. So the first one that we see, use the reduce. And they did the same thing that we did. Exactly the same thing. They passed in a lot of stuff they didn't need to, though. They didn't need their array. In previous, we called accumulator. Names.map. So they took the objects and they turned them, they put all the names in an array. They popped. They joined it on the comma. Plus and plus the last name. They used a bunch of regex here. I don't know, we'd have to Google that to see what's going on there. They have a place to build up the result. They have their comma stored, their ampersand stored, while names.length. Result plus equals names.shift. .name, so they're popping the name off, putting it on there, or shifting the name off. Result plus equals and. Else, if names.length is greater than 1, then they put the comma and they return the result at the end. Cool. All right, so let's maybe do one more. We've been going for almost 30 minutes. So square in sum. So we need to complete the square sum function so that it squares each number passed into it and then sums the results all together. So that seems pretty easy on the surface. Let's do it. Can knock it out pretty quick, I think. Famous last words though. Square and sum. Let's go ahead and save this one. Get it out of here. Title. Function. And our test. Okay, so I'm thinking so we need to look at each number. We need to square. We need to look at each number and square it. Store those numbers, and then we need to sum all of the squared numbers. So anytime you want to do an operation or you want to manipulate each value in an array, a map is usually the way to go. So I think we'll be able to do this one with one line using our map and a reduce. So I think what we want to do is we want to return our numbers dot map. We want to take in our num. So when we map over it, we're going to look at each value, and we want to say math dot pal. We want to pass in our num, and we want to square it. So we'll go 2. So that's giving us each of our numbers squared. You can see that here. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, and so on. So now we need to sum that array. We need to add them all together. So what we'll do outside of our map, because then we'll go dot reduce. Our reduce will take in our accumulator and our num. And we want to say accumulator plus equals our num. And we want to bring that down to a number. And that should do it. 5, 5, 50, 50. How about them apples? Cool. And we could do it as a one-liner. We could do it like, let's say, let SquareSum. And that will take in numbers. Then we'll say, then we'll put this in. We'll do the exact same thing. We don't have to put return because the arrow function has a implicit return. And we could, the way I like to format this is I like to bring, we'll bring our map down and we'll bring our reduce down. And if we save it, it formats it real nice. So we'll go ahead and use this one. Just throw it in. Let's test it. Test passed. Let's attempt it. 46 test passed. Let's submit. Okay. So they just reduced they took in the accumulator and the number. They did the number times the number plus the accumulator. So that's cool. So we could have skipped our map and just done it all inside the reduce. They created some functions to throw into the map and the reduce. Cool. All right, well, I think that's all for today. Thanks for watching. Hope everybody has a great day. Peace.